Well, perhaps some of you can relate to what I'm about to share. I find that I'm somewhat of a skeptic. I'm not easily convinced. Perhaps it's my days at the University of Chicago that has taught me to question the norm and to focus on the why rather than the what and the how. Well, it was only 5 years ago that many CIOs were skeptical about shifting to cloud-based services. They had doubts about security at the physical, network, and the application levels. They had doubts about compliance with the national data protection regulations. And what about the intellectual property and migration? Now, fast forward just a few years, here we are at one of the largest Cloud Expos in Europe. Cloud spending has surpassed $30 billion across the public and public sectors. And according to IDG, IT executives credit cloud-based services for increased efficiency, flexibility, and responsiveness. In 1999, a small startup known as Salesforce.com launched their web-based CRM. Could we be at another inflection point? And that's really what this talk is about. Now, this may sound somewhat audacious to say at a Cloud Expo, but what if I told you that the future is less about the cloud and more about computing on the edge? Just when you're getting comfortable with the cloud, here we go again with another change. I want to talk to you about a why trend. Why is computing on the edge coming sooner than later? And why is that such a big deal? Well, let's first talk about some of the trends, the driving forces. Well, one of those trends has to do with this notion of going from centralized cloud to decentralized peer-to-peer computing. And decentralized computing is the allocation of resources, both hardware and software, for each machine or connected device. Now, in contrast, centralized computing exists when majority of the functions are carried out or obtained from a centralized location, such as in the case of the cloud computing. Now, in a grid model, a peer-to-peer system can run many local computers or internet-enabled devices that can connect remotely to each other to complete a function or a task. Now, this approach to software development affords great savings because we don't have to create a central control point. Let's take a look at today's current network topology, from the end device, internet gateway, to the cloud. Most services today are centralized. They're sharing photos via social networks, uploading files to the cloud. But data concentrated in the hands of a few, effectively an oligopoly, has downsides too, such as a closed proprietary ecosystem that gives little choice or substitutes for consumers. And data ownership resides with big corporations, not us. Decentralization, on the other hand, transfers the power from the proprietary service providers to technology and immutable math, reducing the overhead, improving security, providing more resiliency and higher efficiency. All of you here because of the Internet of Things. Whether you think that it's a nomenclature that's been around for the last 20 years, it's still a force to be reckoned with, given the fact that it's pushing the direction towards decentralized computing, right? The projected billions, whether you think it's 50 or 200 billions, it's irrelevant. But the internet-enabled devices and sensors represent potentially autonomous agents, not dumb M2M agents, but autonomous agents that's capable of decentralized decision-making. And these are entities that make their own choices regarding how to act in their environment without the influence of a central authority. With decentralization, autonomous agents play an increasingly important role in how things work. They will be the brains and the logic residing inside everything from driverless cars to delivery drones to connected home products. They're going to operate individually or in a swarm. They will buy and sell services using cryptocurrencies, pay their own costs to maintain and upgrade themselves. They will be self-sustaining economic units, but without the bureaucracy. And perhaps some of you are skeptics, much like myself. But the transition to a global system that is decentralized, distributed, anonymous, efficient, secure, permission and trustless, no single point of control, no single point of failure. It's inevitable. IoT will be powered by autonomous agents transacting on top of blockchain and connecting to each other via mesh networks. And as more decision-making moves from the application layer down to the agent layer, the global system will start to become more intelligent. Mesh networking, or decentralized networking, as you see here, allows for direct point-to-point connection, which means they can communicate privately and transfer sensitive data. In some ways, it behaves more like a private virtual network instead of going through the public internet network. Mesh networks are peer-to-peer networks created by daisy-chaining your phone to nearby phones using Bluetooth or Wi-Fi. Everyone joining the mesh networks creates an extension to the internet. And the more devices or nodes, the stronger it becomes. It cannot be controlled by any central organization. We've seen that in some of the riots around the world. There is no single IP to block. No governments can shut them down. They're decentralized by definition, self-healing, and remarkably resilient. Mesh networks started taking off with the proliferation of smartphones and the introduction of multi-peer connectivity and Wi-Fi peer-to-peer. For instance, iOS multi-peer connectivity can communicate with other iOS devices without a central hub. Moreover, it allows for chaining P2P connections so that the chain can be indefinitely long. That's pretty exciting. The Open Garden project and their Fire Chat application, if you've used some of them at concerts, automatically creates a mesh network between all the Open Garden enabled devices within reach. And it's able to automatically pick the fastest connection to route that traffic. If one phone is connected to Wi-Fi, other phones can then use that connection to offload their 3G and 4G bandwidth through just that one device. It could also work through multiple devices to increase that bandwidth available to all the devices on the network. And it creates this multi-hop network that you see here. Standards and protocols that some of you are familiar with, IPv6, LoWPAN, and other protocols are in fact enabling this edge-to-edge networking. Let's talk about real-time processing. Another driver for computing on the edge is this requirement for real-time processing. In this example of Boston Dynamics, the four-legged Wildcats robot has to perform real-time calculations to jump over moving obstacles. If you see the video, it's quite incredible. It cannot afford to make a round trip to the cloud and back. It needs to figure out the slope, the height, the force to clear that obstacle quickly. And keep in mind that obstacle can be potentially moving. Another example is the driverless car. If you've been to CES earlier this year, you know this is coming and coming down fast. Driverless cars need to make immediate decisions to avoid collisions or running over people, which frankly humans are better at. They can't afford latency, right? So Google's cars, for instance, they heavily rely on laser and radar scanners. These 64-beam laser scanners sit on top of the vehicles and constantly spin. And these systems, referred to as LiDAR, which stands for laser, light, radar genre meshing, can scan up to 1.3 million points each time they spin in concentric waves that begin 8 feet from that car. Now they're capable of identifying 14-inch object 160 feet away. I mean, that's incredible. Now others are also working on this as well. Oxford uses a series of stereo cameras and LiDAR sensors. Others from the autonomous labs in Germany to Stanford Center for Automation. Automotive research use a combination of these sensors. But the point is, regardless of the sensors that they're using on the vehicle, the goal is the same. Is to gather as much information about their surroundings as much as possible. Now, if you talk to Google engineers, they'll tell you that they prefer to rely more heavily on prior maps that's been captured already, rather than trying to process real time, because it can be error prone. But this shift towards more real-time data analytics is happening. At the International Solid-State Circuits Conference, MIT researchers presented a new energy-efficient chip called Iris. It's essentially designed to implement neural networks capable of handling AI tasks all locally, right on that device, on the SoC. It's 10 times more efficient than a mobile GPU. It allows devices to run powerful AI algorithms locally, rather than uploading data to the cloud and then processing it. No Wi-Fi, no transmission latency. Now this means that from vehicles, manufacturing equipment, to autonomous robots, with deep learning algorithms on board, they can start to have power and performance optimization that we can only dream about. And it allows for complex computations to occur right there natively without ever touching the cloud. Here's another example of SoC that's bringing edge computing power. It's the Intel Curie. Now, I'm not trying to promote Intel per se, but the point is that Intel is just one example of others, and Cube and others, that are developing these small, miniaturized SoCs and microprocessors that is meant to be self-sufficient, to power not just wearables in the form of jewelry and clothing, for instance, but any type of miniaturized devices and end-to-end that requires more processing than a just simple publish and subscribe method. It's based on Intel's 32-bit Core SE, and it contains that standard smart device array of 6-axis sensor, accelerometer, gyroscope, the things that we kind of gotten accustomed to requiring from sensor capture. It has 384 kilobytes of flash memory, Bluetooth, and simple OS. So it's all self-contained, right there in a little coin-sized chip. Blockchain. If you have heard about Internet of Things, you probably have also heard about the buzz around blockchain. Well, the transition from hardware to blockchain cryptography, or decentralized transactions, is another key driver. Now, Bitcoin, as many of you know, is a decentralized cryptocurrency, which just happens to be built on blockchain and represents the largest supercomputing network in the world. Now, Bitcoin really is just an app. That's all it is. But underlying fundamental is the blockchain cryptography. Now, what blockchain is trying to address is this problem of establishing trust between unrelated parties over unrelated network, well, such as the internet. trustless, peerless messaging and file sharing. Blockchain is essentially a massive distributed cryptography ledger-based system that allows sharing among all nodes participating in the node. And it keeps record of every successful transaction and allows for this trustless transactional activity. And it facilitates ownership, storage, transfer, and processing of information without the need for middlemen to serve as an identity information clearinghouse. Now, what this really means is that transactions or identity verification, trust, and reputation, payments become quantifiable and programmable. So let's talk about some of the use cases. And it opens up a whole range of possibilities and business models, such as decentralized voting with Agora, for example, decentralized domain name registration, DNS, such as Namecoin, decentralized storage to exchange storage space and bandwidth, to smart self-validating contracts for real-time revenue share, to document certification to publicly make it visible and to authenticate the timestamp. And we're only just scratching the surface in terms of the possible asset registries and keys that could theoretically be implemented in the blockchain. Now, most of you may have heard of Ethereum and perhaps BitShares. These are enabling developers to be able to build on next generation decentralized apps, or what we call dApps, using the blockchain platform. Perhaps the less obvious driver of computing on the edge is privacy and data ownership. You see, simply, consumers just don't want all their data residing with a proprietary service provider. I mean, I can mention their names because they're not the sponsors of this conference, but the Facebooks, the Googles, the Dropbox. Now, we've seen a number of privacy solutions, but the one that's really intriguing from my perspective is MIT's Enigma. Enigma uses an approach called secure multi-party computation, powered by blockchain, for its privacy-enhancing decentralized computation platform. It's a private data that's stored and shared and analyzed without ever revealing that data to any party. How does that work? Essentially works as a block box without the need to actually share any personal information. You send whatever data you want, and it runs it into the black box and just returns a result or the model. So, for example, the question might be, is this person old enough to drink alcohol at the bar? Instead of sending back their date of birth, other types of PII, what you get back is, yes, this person is old enough to come into the bar and have a drink. The actual data is never revealed. And it's a similar process known as homomorphic encryption, if you're familiar with that. The system allows data to be shared and use it for computation while remaining undecipherable. Pretty amazing. You could also take a look at their white paper, research paper online as well. So what? Who cares, right? What does this all mean? One of the things that, as a skeptic, that I try to focus on is, it's kind of like the IoT. I gave a speech at Mars in Toronto about a year ago. It's not about IoT, but rather, what are the forces, the macroeconomic external forces that's converging, that's aligned for that perfect moment? That's what we're talking about. And why does it matter? I'll give you an example. Photographer Luca Bruno took a picture of a crowd watching Pope Benedict XVI in 2005. Another photographer by the name of Michael Swan took a very similar picture in 2013 at the election of Pope Francis. Now, what do you think was a notable difference between these two photographs? In 2005, hardly anyone was holding a smartphone, whereas in 2013, everyone, the entire crowd, was holding up their smartphones, and you can see the light, starry light, in this photograph. In the last 2 weeks, I've been to Singapore, Kuala Lumpur, Seoul, Beijing, San Francisco, and now in London. What is that one consistent behavior that I'm seeing across the globe? People staring at their mobile phone in the metro. You do it, I do it. Well, the smartphone has ushered an entirely new class of behavior, consumer behavior. And that in turn has reshaped products and services, sales and marketing, and the business models themselves. Uber, Snapchat, P2P payments, to name a few as an example. What we're talking about is massive business model disruptions. DApps, or decentralized apps, being built on Ethereum blockchain gives just a small hint on the possibilities to come. Tomorrow's decentralized world has the potential to change how we democratize voting, notion of collective action, how we reshape industries. New business models will emerge and will destroy traditional businesses, including some of yours. Let's take an example of financial services. The role of financial services as an intermediary of transactions will start to lose its grip. According to the Goldman Sachs report on fintech, changing consumer behavior coupled with innovation in fintech is about to create some massive disruptions. See, millennials, which some of you I see are here, are choosing not to use credit cards, for instance. They're opting for peer-to-peer payments on messaging platforms, such as Venmo. WeChat, for example, is all about commerce and enabling transactions right in the messaging platform without ever having to leave that IM. In just a few years, many millennials, including some of you, will say, I do not need to have a banking relationship. That's profound. According to World Economic Forum, 6 areas are expected to be most impacted by changing consumer demands and the rapid growth of fintech. Payments, deposits and lending, financial markets, investment management, capital raising and insurance. One of our clients is a very large publicly traded financial services technology company. I can tell you that it's not just only about robo-advisor and automated asset allocation. They and the rest of the industry are nervous because whether it's Bitcoins, cryptocurrency, or new business models, things are starting to erode and take away not only their market share, but their bottom line. I've been invited to speak at an insurance conference to talk about how IoT and some of the fundamental drivers that I'm talking to you about is going to change insurance. Massive. Car insurance, life insurance, P&C. Imagine how decentralized computing on the edge with blockchain and cryptocurrencies will reshape crowdfunding, alternate lending, new market platforms into a purely cashless society. Most of us have an impression of what the internet is, right? You may or may not be aware of this, but we are in the midst of redefining the internet itself. The internet is defined as a global network of computers consisting of this interconnected network using standardized communication protocols. Well, in other words, these networks represent the large data centers or the cloud servers, right? As well as the academic research labs and your individual desktop machines. We're using the metaphor of dust particles. The network topology is about to change massively to a wireless sensor network of P2P with the smallest footprint end-to-end. So literally, I could actually put a small sample of sand on my hand, blow it, and that sand just permeate just about everywhere, walk into the air, and be affixed to things around us. That's the future of where IoT is going. It will be embedded into the carpet, into the paint, into the ceiling. The light fixture and the Wi-Fi, that's just the beginning. And those little nodes, those little devices, those little dust particles will connect with each other, not with the internet, will connect with each other. The future network topology is a peer-to-peer mesh network. And the reason this is important is that this is going to forever change the traditional telecom carriers and broadband providers. Imagine, for them, for years, they've been incumbent oligopolies, and in some countries, monopolies, enjoying fat margins. Well, how is this going to potentially bypass their infrastructure? I mean, if you thought that voice over internet protocol was hugely disruptive, like Skype, what I'm talking about is massive game changer that's going to change the fundamental landscape of what we perceive as telecom. On the consumer and regulatory fronts, there is a heightening sensitivity and active policy measures being taken to protect personal data. So I was speaking with a couple of colleagues yesterday, and they're talking about GDPR as an example in Britain. Ultimately, they don't want any one company owning your data. Your data is yours, right? And as data begins to reside on the edge and not centrally on the cloud, this will begin to shift that equilibrium away from the proprietary service providers to us, the individuals. It means that home automation devices, for instance, will store and manage the security, the authentication, the encryption, and that privacy policy all locally to ensure that the personal data that's being captured on that home automation device, whether it's Amazon Echo or Automation Hub or controller, resides and is protected and is following your preferences. Rather than giving that data to others, third parties, just freely, and letting them monetize off your data, blockchain ledger cryptography, which I talked about previously as an example of Enigma, will allow for you to protect your data, but still allow others to be able to query your black box, and then send back simply just the model or the result of that query, without ever having to actually reveal your data. That's the future. The future is that nobody's going to really own this data, but we're simply going to ask permission and ask questions. When we think about IoT, many of us default to thinking about small end-to-end nodes that uses this publish and subscribe standards and protocols that passively just transmit data, right? This is the case of manufacturing and John Deere and some of the others, for instance. But the future of IoT is actually much more. It's about intelligent, autonomous things that's capable of independent thinking, independent real-time capabilities, and interactions and workflows and automation with itself and with other nodes. Now think about in the case of mining robots. We've seen many disasters around the world where people have been caved in mining mines. Well, you can now start to send robots instead, and they can work independently. But what about deep water submarines that don't require remote control? Or autonomous robots in deserts, for instance, where you have oil refineries. Everything is handled locally without the need for traditional internet connection for operation. So what is the takeaway? As a skeptic, yes, I agree that the transition from cloud to edge computing will take its time. And there's going to be many technical challenges to overcome. But the future of edge computing alongside cloud isn't that far off. The mix of cloud and edge computing is going to eventually swing to edge computing for reasons of faster local processing, low latency or no latency, and improved security and privacy. Focusing only on the cloud and not analyzing how computing on the edge could disrupt your business could mean the difference between creating a game-changing business transformation or obsolescence.